Welcome. In this video, we're going to look at solving an equation which is not quadratic. You see the equation given here is x to the fourth, but it is reducible to quadratic. And we're going to reduce it using what we like to call in the math world a u sub or a u substitution. So what we want to recognize is that this x to the fourth minus 5x squared minus 50 being equal to 0. This looks quadratic, but again, it's x to the fourth, which is technically a quartic equation. But if we think about x to the fourth, well, x to the fourth, that's the same as x squared times x squared. So really what we have here is x squared minus 5x squared minus 50 equals 0. What I'm going to do, since I see that I have these x squared terms, is I'm going to come over here and say, well, let's let the variable u represent x squared. So I'm going to reduce this from being a squared term to a linear term. And if I do that and I plug that in, I'm left with u squared minus 5u minus 50 equals 0. At this point, you should notice that we have a quadratic equation, u squared minus 5u minus 50. So essentially, I used this substitution to reduce the degree or that high power that we were dealing with. Now, since this is a quadratic equation with a leading coefficient of 1, this is easy for us to factor. And there are two factors of negative 50 that are going to add to give us negative 5. So if we think about factors of negative 50, we might try negative 10 and 5. And if I add those together, I get that coefficient on my linear term, negative 5. So this would be u minus 10 and u plus 5 is equal to 0. By the zero product principle, we can solve each of these, and we've got u minus 10 equals 0, as well as u plus 5 equals 0. And solving each of those linear equations, we will determine that u equals positive 10 or negative 5. And at this point, you might think, hey, we're done. But we're not done, because what we have completed here is we've solved for the variable u. And the original problem started with x. But if you recall, we said, hey, let's let u represent x squared. So what I'll do here is I'm going to say, well, this means that x squared equals 10. We had u equals 10, x squared equals 10, as well as u equals negative 5, or x squared equals negative 5. So now I have two basic quadratic equations, and I can solve each of these using the square root principle. And remember, if we use a square root to solve, and I take the square root on both sides of the equation, we must write a plus or minus. So this is going to end up being x equals plus or minus the square root of 10, as well as x equals plus or minus the square root of negative 5. And writing all four of our answers out, that means we have x equals positive root 10 and negative root 10. And dealing with the negative under the root 5, we'll have positive I root 5 as well as negative I root 5. So here we have 4 solutions, 2 real, unique, irrational solutions, and 2 complex or imaginary conjugate solutions. And something we'll learn later in the semester is that these irrational solutions, as well as complex solutions, they always occur in conjugate pairs. So we got 4 answers. I want to go back up here and connect with what we started with. Remember, this problem, when we began, we were solving x to the fourth. So x cubed, we have seen an example. X cubed, we have 3 solutions. X squared always has 2 solutions. x to the fourth is going to have 4 solutions, and that is not a coincidence. So anyhow, that is how we solve a problem using the substitution method. And we use that substitution method to reduce from x to the fourth down to x squared squared or u squared. So we turned quartic, fourth degree, into quadratic, second degree. As always, reach out if you have any questions because I am here to help. Have a great day.